Alrighty, so we are moving on to rhombuses and rhombi and rectangles today. And so I'm gonna make this video first for you to watch. It's another visual aid video because I want to show you where the properties that we're going to talk about in the notes, I want to show you where they come from. And so I have constructed a rhombus here. We're going to start with rhombus. And so I can show you that it's a rhombus because remember, a rhombus has every side length is the same. And so I just went and measured every side. So every side length here is 7. And now, remember, a rhombus is an offshoot of a parallelogram in that every side of the rhombus is the same. So, and because it's an offshoot of parallelogram, all the parallelogram properties we talked about, opposite sides congruent, opposite angles congruent, same side angles are supplementary, and diagonals bisect each other. All those still apply to a rhombus. But now a rhombus has 2 special properties that come with it. That's what this video is going to look at. And they both deal with diagonals. So the first thing I'm going to do is we're going to look at what happens when the diagonals meet here in the middle. Okay, this actually might be the second property from the notes, but it's fine. It doesn't matter what order they're in. So I'm going to measure these angles all these angles right here. Okay, there's 4 different ones. So let me measure those angles. CAEA. Actually, I'm just going to do 2 of them. All right, so those 2 angles right there, they formed little boxes, and they put the number there 90. Of course, we know that those boxes mean 90 degrees. And so we can say that, and obviously we know that these other 2 are going to be 90 degrees as well. So every angle right here is 90 degrees. And so what we say is the property is that when the diagonals intersect each other, they are perpendicular. Perpendicular means that 2 lines or segments intersect with each other, and they form 90-degree angles. So the first big new property for a rhombus is that the diagonals are perpendicular. Okay? Now we're going to look at what happens when the diagonal intersects the opposite angles. So I'm going to measure this angle and this. Actually, let's do this. So let's find out what the big measurement, the actual angle is. So that angle is, I'm going to put it out here. So that entire big angle is 120 degrees. Now I want to see what happens when we measure each little piece. Okay, so A, C, E, B, C, E. Okay, so look at that. This entire angle 120 has been cut in half, essentially, because 60 is half of 120. I wonder if that happens all the time. Let's go see. There's another 120. Remember, opposite angles are congruent, so the fact that these are 120 shouldn't surprise us. Now let's see what happens when we measure the pieces again. Okay, so this pair of opposite angles, they're both congruent at 120, and then when the diagonal intersects the angle, it cuts it in half. Wonder if that's true for the other one, so let's see. Oh, I forgot to click it. That's funny. Okay, so let me move that. So that the big angle there, the entire angle there is 60. Oops, wrong one. There we go. I think we'll get the other ones. All right, now let me resituate everything so we can see what we're looking at here. 30. Oh, that's a 60 goes out there, and then a 30 right here. So look at what's happened now. I'm gonna hide some stuff. All right, so I removed the 90s. Actually, I don't want to do that. So I put the 90s back. Well, now I gotta move all that stuff again. That's what I get for playing around with this thing. 60 out there, 30 here, 30 here. Okay. So again, these two angles that are 60, that's the entire angle here. Those are opposite angles and they're congruent, which is what we expect to happen. But then when the diagonal intersects the angle, it cuts it in half again, because 30 is half of 60. And that happened for every pair of opposite angles. See that in here? So the second property for a rhombus is that each diagonal bisects or cuts in half a pair of opposite angles. So in other words, when the diagonal meets the opposite angles, it's going to cut them in two equal pieces. Okay? So those are the new rhombus properties. The diagonals are perpendicular, and then the diagonals bisect opposite angles. Okay, so let's go look. Now let's look at a rectangle. So here's a rectangle. Again, a rectangle is an offshoot of a parallelogram in that every angle in a rectangle is congruent. And of course, we should know that every angle in a rectangle is going to be 90. And I'll just measure two of them just to show you. Right? So a rectangle is a parallelogram with four congruent angles. Okay? So every angle here is 90. And then all those properties, again, that we talked about for parallelogram. Opposite sides congruent. Opposite angles are congruent. The same side angles are supplementary. And then the diagonals bisect each other. That happens too. So all those properties apply to a rectangle. But the rectangle has one extra property that comes with it, and it involves the diagonals. So what I'm going to do is measure the entire diagonal, AD. Let me move it out of the way. All right, and then I'm going to measure CB. Now look at that. So AD is 8.9 and CB is 8.9. So the property for a rectangle is that the diagonals are actually congruent. They're the same length. They still cut each other in half, okay? But it just so happens that the entire length itself is the same. And so we can also see it with the little pieces. Let me move all these where they go. So look at this now. Because the diagonals are congruent, every little piece of a diagonal is the same length. That's what makes it different from a parallelogram. Because remember, when we looked at just a parallelogram, maybe this pair that I'm pointing at was the same. But then this pair would be different because their diagonals were not congruent. Here, they are congruent. And that's why every little piece is the same. Okay, so the big thing for a rectangle is now that the diagonals are congruent. They're the same length, and every little piece is going to be the same length. Okay, so that's your visual aid video. So make sure you watch this, and then we go watch the notes video to learn how to use these properties. Okay?